All right, today's topic is solving literal equations. Literal equations are different than regular equations that we're used to because they don't have all of the numbers that we're used to. They have a bunch or multiple variables. So sometimes you will see an equation with a lot of different variables, usually like a formula or something, which this one over here does look like a formula. This is just something that's made up and they just threw a lot of letters in it. The thing you do with solving multiple equations is you're going to do it the exact same way that you would kind of use your algebra skills for regular equations. So I'm still going to go to this equation and I'm going to put a line down the middle. Now the weird thing is that we have a bunch of variables here, a bunch of missing pieces. We got to figure out what we're actually looking for. So for the first example, I'm going to be solving for X. So you should be writing this in your journal. I'm going to kind of be all over the board here. You set up your journal page however you want, okay? So if I'm solving for X, I first got to locate X. X is right here if you couldn't see it. But what I'm going to have to do is isolate X. Remember, I want X to be all alone on this side of the equals, saying that it equals something. Now, of course, we're not going to get a letter or a number answer, but I just want you to see what's going to happen. First of all, let's take away the step that we know. Just like this was a two-step equation, which it looks like it's set up that way, except it doesn't have numbers like we're used to. Let's add this b to this side, or let's take this b and add it over here. The only thing is we're not going to add, we're going to subtract b, just like we use our inverse property. And then I'm going to subtract b from here. Now, b minus b is canceling out. That's why we do it. You're probably looking at this like, what? How do you take c and minus b? That makes no sense. Well, that's what it's supposed to do. It's supposed to make no sense. You can't take c and minus b and get an answer. So instead, we just write c minus b. This ax we did nothing with. And the last thing we do, this x and this a and this x are technically multiplying by each other. When variables sit right next to each other, just kind of like a number and a variable do, they are multiplying. So we're going to divide by a on both sides of the equation. So I divided by a. So our answer is now, and I'm going to move this just a little bit down so I can have some room to write. X equals c minus b all over a. There you go. That is how we solved for X in this equation. If we were told to solve for B, something different than X, we would have had to locate what we were trying to solve for and then move everything else away from it, okay? So in this equation, we're going to solve for B this time. We don't have an X, we don't have anything else. We're just gonna say, let's solve for B. Let's figure out what base equals. If you might have noticed that this is the area for a triangle formula, and sometimes you may be asked to change the formulas around the way you want them to look. Okay, so if I was solving for B, I'm going to first locate it. There's B. Draw my line in the middle. And now I have to understand that this 1/2 is being multiplied times B, which is being multiplied times H. In order to move things around, I'm going to do the opposite of multiplication, which is division, just like I'm using my inverse property. Let's try to get B all alone. So first, let's divide by H. Or, I guess I can get rid of the numbers. We can honestly do either one first. Let's do the numbers. So first is 1/2. If I were doing the opposite of 1/2, remember we actually did a reciprocal a long time ago at the beginning of the school year. We learned that multiplying by the reciprocal is actually the opposite of multiplying by a fraction. So it's kind of like the whole keep, change, flip thing. If I multiply by 2 over 1, it technically cancels out. So this 2 cancels out. It's basically like saying 2 divided by 2, which is 1. I have to do the same thing over here. 2 over 1. That's just 2. So I probably could just write 2 if I really wanted to. But just to keep y'all understanding what's happening, I'm going to say 2 over 1. 2 times a is written as 2a. And then I'm left with this. This goes away. Remember that these made it cancel out. I'm left with b times h. We're still solving for b. B is not only by itself, so I'm going to divide by h on both sides. It goes away here. I am left with 2 times a divided by h equals b. That is my answer. I solved. All right, this is our last example for literal equations. This looks closer to an equation that we're used to. However, there's still two variables here. We can't do anything. We can't solve this all the way. We need one variable. We need to just see x, or we need to just see y, but since we have two variables, it's not gonna solve the exact way we want it. Let's pretend that this question wanted us to solve for y. Okay, so first we're gonna locate it. It is right here. I'm drawing my line just like normal. I need to get y all by itself. Right now we have this 5 next to it. We also have this 4x added to it outside over here. Now remember in solving equations, we kind of worked with this stuff that added and subtracted first. So let's take this 4x and move it to this side. We are used to doing this. We would have subtracted 4x from both sides to move it. However, we were used to putting it with like terms, right? These aren't like terms. 30 minus 4x, we can't do. We don't know the exact value of 4x because it's multiplied by that hidden number. So what we're gonna have to do is this one cancels out. I rewrite 5y, and since I don't know the answer to this, I'm just gonna rewrite 30 minus 4x. Okay, and then last but not least, we have this 5 multiplied to the y. So let's go ahead and divide both sides by 5. And notice I do the entire side of this equation divided by 5. 5 cancels out, I get y equals, and then the way the distributive property worked is we took one number and multiplied it by everything inside the parentheses. This is kind of the same way. It's almost as if these were parentheses and each piece is going to be divided by 5. So 30 divided by 5 is 6. Negative 4 divided by 5, remember I consider this a negative 4, is, doesn't do anything, it's a fraction. Negative 4 over 5, x. And we solved for y. So yes, this doesn't give us an exact answer, but it gives us a basic idea of what y would be if we were looking for it.